What is up, geometry? This is lesson 8.1. We're going to be talking about geometric mean. Before we talk about geometric mean, just do a quick recap back to what an algebraic mean was, except for we just called it a mean of two numbers or the average of two numbers. So we're like, hey, what's the average of 2 and 6? So we would just add those two together. We'd say, oh, 2 plus 6. And we divide by 2 because that's how many numbers there were. We'd say 8 over 2, so that would be the average of those is 4, right? So that's the algebraic mean. Well, today we're talking about the geometric mean because we're not in algebra class anymore. We're in geometry class. So geometry class, we're talking about geometric mean. And instead of adding and then dividing, what we're going to do is we're going to multiply. We're going to say A times B. And then instead of dividing, we're going to take the square root, right? So we're going to take the square root of A times B, and that's how the geometric mean is defined. So let's go ahead and just try those real quick. If we did 5 times 15, this gives us 75. So I'm just going to say 5 times 15, and then I'm going to take the square root of that. That's the same thing as 5 times 75. I see that there's a perfect square in there, so that means it's going to be the square root of 25 times 3. Remember, the square root of 25 is just 5, so this would be 5 square roots of 3. Okay. Over here, if I did 12 and 15, that's going to be the square root of 12 times 15. That's going to equal to the square root of 180, which is going to be square root of 36 times 5, which is going to be 6 square roots of 5, would be our answer for that one. Sometimes it'll work out nicely, and it comes out to be a whole number, but in these cases it did not. It's also, I guess, worth noting over here that the definition of a geometric mean, notice with the same thing, just that some number divided by x is equal to that same x divided by b. So those two match. So if you cross multiply x times x is the x squared, 8b, and then you take the square root, x equal to ab, which will kind of help us out here on this next slide. So this is theorem 8.1, and it states that if you take a right triangle, like this one, triangle ABC, and you draw an altitude here to its hypotenuse, this triangle here, then you get two other triangles, and let me see if I can just draw these for you. Here's this little green one. Has a right angle right there. That's this green one right here with the right angle. And then let's do this one. Blue has this blue triangle here with the right angle. So this would be that blue triangle there. Okay, so notice this point right here by the right angle is D, this point up here is C, this point over here is A, right? B up here, D right here, this length C. Okay? Now, if we label each of these sides with lengths, let's call this one lowercase a, this one lowercase b because it's across from the b, this one lowercase c, and we're just going to call this one the height of that triangle. Then we also have to label this length right here x, that's just the BD length, and then this one here y, which is from A to D. Okay, so that means this one down here is going to be y. From B to D is x. From B to C is A. From C to D is this h. Over here on the blue one, C to D is h, and then C to A is at length b. So theorem 8.1 simply states that these three triangles come out to be similar to each other. Because they're similar, we can do ratio lengths. So let's just do the short leg to the long leg. So let's see here. The short leg over here is going to be, on the big black one, is going to be A over B. A over B. That would equal to h over y on the blue one, and x over h. X over h for the green one. So if you, okay, now let's try the next ratio here. So for the big one, maybe I should do different colors. The big one, the hypotenuse over the short leg is going to be C over A. For the blue one is going to be B over H. For the green one, it's going to be A over X. And then for this last one here, for the hypotenuse over the long leg, it's going to give me C over the length B. For the blue one, it's going to be B over Y. And then for the small green one, it's going to be A over H. Now we don't necessarily need all of them here, but notice how this has an H on the top and an H on the bottom here. So we can kind of use the geometric mean definition with those two ratios. This one has an A on the bottom here and an A on the top there, so we can kind of use it with those two ratios. And then this one has a B on the top and the B on the bottom, so I could use those two ratios to compare. And that is going to bring us to our next theorem if we kind of expand that out. So that means the H, that's not what I wanted, means the H would equal to the geometric mean of X and Y. The A would equal to the geometric mean of C and X. And the B is equal to the geometric mean of C and Y. So just kind of compare those up here. H, that's this length right here. So that length is equal to the geometric mean of these two pieces. A, this length, is equal to the whole length, the geometric mean of the whole length in this piece. And B, this leg, is equal to the whole length times this piece of it, which is exactly what these next two geometric means refer to here, or the next two theorems. So we're going to call this length H, this length from here to here we're going to call X, and from here to here we're going to call Y. So the altitude theorem simply says that H is equal to the geometric mean of X and Y. And then for the leg one, we have two different ones. If I want this leg A, that's equal to the geometric mean of the whole length times the piece that's next to it. So C times X. And I can kind of apply that same rule if I want B. It's going to be, I should use a different color, B is going to be the whole length times the piece of the leg that's nearest to it. So it's going to be C times Y. So let's go ahead and try this real quick. Let's see if I can squeeze them in here. I didn't give myself much space. But we're supposed to find X, Y, and Z. So first off, let's find that Z. So Z is just going to be the geometric mean of 8 and 25. So Z is equal to the geometric mean of 8 and 25. It's going to be the square root of 200, which is going to be 10 root 2, because that's 100 times 2. Square root of 100 is 10. And I said it, but I didn't write it. So that's what Z is equal to. If I want to find out what X is going to equal to the square root of 8, remember this piece next to it, times the whole length. The whole length is going to be, let's see here, 8 plus 25, which gives me 33. Which is the same thing as the square root of 264, which Actually, the only perfect square that's a factor of that is 4, so it comes out to be 2 square roots of 66, which is about 16.25. And then for y, I'm going to do something similar. For y is going to be the square root of 25 times 33, right? 25, this length over here, times the whole length. Well, that's just going to be 5 square roots of 33, which is a 12.85. Okay, so those are my 3 answers. Here's what z is equal to, x is equal to, y is equal to. One more over here. Here my x, y's, and z's are a little bit different places. So in order to find z, I need to use this length and the whole length. In order to find y, I need to use this length and the whole length. So I think it's going to be really beneficial for me to find x first. So here we go. If I want to find that x, I know that 12 is going to equal to the geometric mean of these two pieces. So it's going to be the geometric mean of x times 9. Well, that means 12 is going to equal to 3 square roots of x. If I divide both sides by 3, I end up with 4 is equal to the square root of x. If I want to know what x is, not the square root of x is, so I'm going to square both sides. And end up with x is equal to 16. That's really helpful. So this length over here is now 16. That's my first answer. Now let's see if I can find y and z. So here's y. Let's see if I can squeeze it in over here. Y is going to equal to the square root of this side right here, which is 16, we just found that, times the whole length, which is going to be 16 plus 9, oh, that was a really horrible 9, which is 25. So it'll be 16 and 25. Those happen to both be perfect squares, so y is going to equal to 4 times 5. So y is going to equal to 20. That's my next answer. And then I need to find z. So it's going to be this length right here, which is going to be 9 times the whole length, which we already found out is 25. Again, those are perfect squares. Square root of 9 is 3. Square root of 25 is 5. So that means z is equal to 15. If you haven't noticed, your homework is on page 569, and you're going to do those first 7 problems. Feel free to watch this over again. Feel free to contact me if you need extra help. You guys are gonna do awesome.